Okay. Question number 1 is the easiest one. How many degrees equal pi radians? Pi radians equal to 180 degrees. And how many revolutions pi radians? Half revolution. Distinguish between the linear speed and angular speed. So linear speed is defined for linear motion. Yani if you define the motion of an object by length, it is called as linear speed, meter per second, kilometer per hour. So we are measuring the motion by length, yani distance. But angular speed is, we define the motion of an object by angle, radian per second, acceleration, radian per second square. Yani if a motion can be circular motion, when an object is defined by angle, so speed, that speed will be named as angular speed. A linear speed, if the same circular motion is defined by distance, that speed is called linear speed. Then question number 3. When a wheel rotates about a fixed axis, do all points on the wheel have the same angular speed? Yes, because one point is rotating some angle theta, all points rotates the same angle theta, and they have the same angular displacement in the same time interval. So if they have the same angular displacement in the same time interval, same divided by same, result is same. Angle speeds are going to be the same. And we also said that for a rigid object, all rotational quantities are the same for every single part on a rigid object. And question number 4. A car on a Ferris wheel has an angular displacement of 0.34 radian. If the car moves through an arc length of 12 meters, so the car is in circular motion, arc length and distance traveled by the car is 12 meters. What is the radius of the Ferris wheel? Of course, we are going to use angular displacement arc length relation. Delta theta is equal to delta s over r, then r is equal to delta s over delta theta. Answer is 25.3. It's an easy one. Question number 5. In fact, it's also easy, but this question number 5, sometimes the student cannot understand what this question is talking about. Questions talking about what? When a wheel is rotated through an angle of 35 degrees, which is angular displacement, a point on the circumference travels through an arc length of 3.5 meter delta s. When the wheel, same wheel, rotated through angles of 35 radian, again angular displacement, and 35 revolution. Yeah, you are going to rotate the same wheel at different angular displacements. That's why I'm going to label them. The first one is delta theta 1. One is delta theta 1. Delta S1 is going to be 2.5. When it is delta theta 2, when through the angles of 35 radian, delta theta 2, and revolution, also angular displacement, delta theta 3. The same point, which means they have the same radius. Yani, there are the same point define its motion 3 times. In one of them, it turns 35 degrees, arc length is 2.5. In the second one, it turns 35 radian. In the third one, it turns 35 revolutions. Of course, their arc length should be different. So the same point travels through the arc length of 143 meters. This one, 143 and 900 meters respectively. Respectively means if delta theta 2 is the first one, in here the first one is going to be delta S2. It's going to belong to 35. 35 and 35 revolution. 143 and 900. So this 143 belongs to delta theta 2, and it is delta S2, and this is delta S3. Delta S3. Because same point, so if the same point, radius must be the same. Yeah, you are going to calculate radius from the first given, then you will use this radius for the other 2 given. So let's get the radius from the first given, but first we should convert radian to degree to radian by any equation anyway. This is, I use the equation in the book, which is 3 pi over 180 times 35, which is 0.61. Now we use the equation for delta theta is equal to delta S over R, cross product, R is equal to delta S over delta theta, and then put it here. Delta S, how much? 2.5. And how much is delta theta, which 0.61? Did we get the radius? Now we got the radius of the point. Then, same point. Now R is going to be the same for other two angular displacements. How by the time? Because point is the same, in fact, we will calculate the same R. Yani in the second one, in the third one, you will calculate same R. 2 same. If the point is the same, R must be the same. See that? Yes, they are going to be same. R, delta S over delta theta. So what was the delta S2? How much? Here delta S2 was 143. What was delta theta 2? 35. So delta S over delta theta. Again, R. Divide them by, it was, yeah, this one. 143 divided by 35 radian. Again, we will get same radius because same point should have same radius. The same again point, yeah, same radius. Delta S over delta theta. But this time, delta S is how much? Delta S3? 900. Or what is delta theta 3? 35. That's revolution. We should convert it to radian. So you are going to multiply 35 revolution by 6.28 on 900 divided by this. You will get again the same number. Yani same points radius will be calculated 3 times in this problem. Of course, such a question you cannot ask. One of them is going to be missing question, not all of them. So this is what makes students confused, especially this part. Yeah. Questions part. Yes, last one. Yeah. 6 one. How long does it take the second hand of the clock to move through 4 radian? This is, remember, the most popular question in history in this title. There are several ways, but my way is the shortest way. Okay, so we know that one rotation corresponds to an angular displacement of 2 pi, 6.28 radians. So every one rotation, doesn't matter what is rotating. Minute hand, second hand, clock hand, earth, moon, car, whatever it is. So every one rotation, revolution, 6.28 radians. So I am going to write it. One rotation force, because questions about second hand, I know second hand completes one rotation in 60 seconds. Then 4 radian takes how many seconds? So I have to use radian. But here we use rotation. I know one rotation is how many radian? How many? 6.28 radian takes 60 seconds. Then 4 radian takes how much? So cross product. Fine. 28 times x is equal to 4 times 60 and divide by 6.28, result is 30.2. And question number 7. A drill starts from rest after 3.2 seconds of constant angular acceleration. The drill turns at a rate of 2,628 radian per second. So find the drill's angular acceleration and also determine the angle through which the drill rotates. Okay, angular acceleration, of course we should use the definition of angular acceleration because angular speeds are start from rest. Initial angular speed is 0. After 3.2 seconds, which is delta t, of constant angular acceleration, the drill turns at the rate. In fact, this is the definition of the angular speed. Rate of rotation. Rate of rotation is angular speed, so this is fine. Also, you can get by the unit radian per second is omega final. Omega initial is 0. Omega final is 2,628. Time delta t 3.2. So calculate alpha. Then calculate angle through which the drill rotates. It is definition of what? Angular displacement. The angle through which an object rotates in a specific direction is called angular displacement. And in the question they are giving definition to you. If you read the questions, carefully read the question, you can see that. Delta theta is the question. So angular acceleration, I'm going to use definition of angular acceleration, which is omega final minus omega initial divided by delta t, and omega final is 2,628. Initial is rest, yani 0, divided by time, which is 3.2. Result is this number. We got the answer and angular displacement. Initial speed is given. By the time, this is an accelerated motion. Accelerated motion. In accelerated motion, we have to use kinematic equations. So omega initial is given, omega final is given, delta t is given. So which kinematic equation fits? Of course, omega initial plus omega final divided by 2 multiplied by delta t. In fact, this is normally coming from cross product. Delta t is equal to omega average times. So for an accelerated motion, how do we calculate average? Initial plus final divided by 2. Initial plus final. Sometimes students write that in final minus initial. It is delta V, not average. Change. Change is final minus initial. Average, initial plus final divided by 2 because it is accelerating with constant angular acceleration. No, it's not that one. So if you write omega average in place, this is what it is. You'll get this equation. After that, insert everything. So initial is rest 0, final is 2,628, divided by 2, multiplied by 3.2, result is in radian. But if you want to convert it to rotations, you should divide by 6.28. And question number 8. When a wheel rotates about a fixed axis, do all points on the wheel have the same tangential speed? What do you think? Tangential speeds. Wheel is a rigid object. In a rigid object, all rotational quantities are the same for different points. Yani same angular displacement they do, same angular speed they move, same angular distance they accelerate. But linear quantities are different depending on the circle size, yani radius. Remember, let's remember the equations. Delta S is equal to R times delta theta. V, linear speed is equal to R times omega. A, linear acceleration at the tangential acceleration is equal to R times alpha. So these three are the same for 2 or 3 or 4 or 5 different points. These three are same. But this three linear quantity depends on radius of the circle. Yani if radius, there are points are on the same radius, if the points are on the same radius, so then you can say that they have the same tangential speed. They can have, but they have to be on the same circle. Like 2 horses on the same distance to the x rotation. So the angular linear speed is going to be, and tangential speed is going to be the same. But if the points are moving in different circles, different size circles, small circle, large circle, or larger circle. So in this case, tangential speeds are going to be different for different circles. On the same circle, if there are 2 horses, they will have same tangential speed because they have the same distance from the axis of rotation. Did you get it? Okay. Did you okay? Do all points on the all points, not all points. Only the points at the same distance from the axis of rotation will have the same tangential speed. But all other points at different distances will have different tangential speed. Not only tangential speed, different tangential acceleration, different arc length. Correct the following statement. The racing car rounds the turn at constant velocity at 145 km per hour. And what is the problem with this statement? Why should we correct it? Why should we correct it? Because it is rounding a turn, rounding more circular motion, circular path. And if an object moves in a circular path, what is changing? Direction of velocity. So direction of velocity changes. Yeah, your velocity is changing in a circular path. Maybe in magnitude it can be constant, but in direction, never constant. That's why we cannot say that velocity constant, because velocity is a vector quantity, and when we say a vector is constant, it must be constant with the magnitude and also must be constant with direction. In this case, we can say a vector is constant. If we say velocity constant, object must move in a straight line path, absolutely, with the same speed. So, if an object moves a circular path, velocity can never be constant. So that statement is correct. If I want to correct this statement, racing car rounds the turn at a constant, yes, I can correct this. Because speed is a scalar quantity, we can keep it the same number on the circular path. And question number 10. Describe the pedal of a moving body whose acceleration is constant in magnitude and constant in magnitude all the times, but it is perpendicular to velocity. Only one acceleration is perpendicular to velocity. AC. That is centripetal acceleration. So AC is perpendicular to velocity. AC is measured for circular path. This object is moving absolutely circular path. But one more thing. This acceleration must be constant in magnitude. Yeah, AC must be constant, unchanged in magnitude. So I will use the equation. AC is equal to V squared over R. If it is unchanged, yeah, because I know for a circle it is unchanged, if it is just one circle. If result should be unchanged, V also must be unchanged. Yeah, V must be constant speed. The object must move in a circular path with constant speed. It can be constant tangential speed, also can be constant angular speed, because in circular motion, tangential speed and angular speeds are related by the equation Vt is equal to R times omega. If Vt constant, omega must be constant too. Okay. Then this object must move in a circular path with constant tangential speed. In this case, centripetal acceleration exists, and this acceleration all the time, same number. And then continue. Question number 11. An object moves in a circular path, this time again with constant speed v. Circular path, yapıştır. Neyi yapıştır? AC. If an object moves in a circular path, AC absolutely exists. AC is not zero. But this object is moving in this circular path with constant speed. Alright? A. Is object's velocity constant? First, velocity is a vector. If velocity is to be constant, object should move in a straight line path. If it's moving, then we cannot say velocity constant. It is not. B. Is the acceleration constant? It is moving constant speed. Constant speed means tangential acceleration is zero. Tangential acceleration is zero. When it says zero, its acceleration is constant. It's talking about in a total acceleration. They don't say it, but total. And I know total acceleration equation. Remember? A total is equal to AC squared plus AT squared squared, but AT is zero. And so A total only? Yes, only AC. A total is only AC. Then if acceleration constant, it must be all the time in one direction and with the same magnitude. No, yes, same magnitude, correct, because speed is constant. Constant. Yani V is constant, so AC is V squared over R. So R is same, V is same, AC is same, constant in magnitude. But look at the direction. Direction is changing. Left, down, right, up, left, down, right, and so on. If a vector is constant, its direction shouldn't, but it's changing. In this case, we cannot say it. But can we say acceleration is constant in magnitude? Yes, we can. Acceleration is constant in magnitude because V is constant, R is constant, it doesn't change, so our result doesn't change. but direction changes. That's why acceleration is not constant, but acceleration is constant in magnetic terms. Okay. Next, give an example of a situation in which an automobile driver can have a centripetal acceleration but no tangential acceleration. It's very easy. Centripetal acceleration, circular path. It must be moving in a circular path. But no tangential acceleration means tangential speed be constant. Tangential speed must be, bt must be constant. Yeah, this object must be moving in a circular path with constant tangential speed. So the automobile moves in a circular path with constant tangential speed. So the driver has a centripetal but no tangential acceleration. And 13. Can a car move around the circular track so that the car has a tangential acceleration but no centripetal acceleration? Circular racetrack. No centripetal acceleration, impossible. Because circular track means AC is not zero. But it says 0. No, it's impossible. So the car will have absolutely centripetal acceleration if it's moving in a circular track. Tangential acceleration tangential acceleration possible if the car is slowing down or speeding up. Yani tangential speed should change, then AT possible, but AC part wrong. In circular path, always there is centripetal acceleration. Question number 14. The gas pedal and brakes of the car accelerate and decelerate the car. In here, what they are talking about is this. When you push the gas pedal, car speeds up. Yani, in here, when it says accelerate, it's talking about speeding up. Speeding up. When you brake, decelerate. Decelerate means slowing down. Yani, this statement is talking about speeding up and slowing down. Then, could a steering wheel perform either of these actions? Yani, can a steering wheel speed up or slow down a car? No. What does steering wheel do?
Just change direction.
How can you turn your car? By steering wheel. Yani, you are changing direction. Steering wheel cannot speed up the car, cannot slow down the car, only changes direction of motion. That's why it cannot. If we say that, just we think about quantity as a quantity, you can say acceleration. Speeding up produce acceleration as a quantity. Slowing down produce acceleration as a quantity. Steering wheel produces acceleration as a quantity, centripetal acceleration. But first sentence is not talking about this. It's talking about speeding up and slowing down. Yes. Gas pedal speeds up the car. Brake pedal slows down the car, but steering wheel cannot do these directions. It only changes direction. Question number 15. A small pebble breaks loose from the treads of a tire with a radius of 32 centimeters. If the pebble's tangential speed is 49 meters per second, what is the tire's angular speed? Omega, very easy. You know, Vt is equal to R times omega. Omega is equal to Vt over R. Vt is given, R is given. Find the answer. And next, a building superintendent throws a set of keys in a circle at the end of a cord, just like my pendulum in the classroom. If the keys have the centripetal acceleration of 145 meters per second squared and the cord has a length, the length of the cord is going to be time radius. What is the tangential speed of the keys? So we know the same question with tangential speed. First one, that is equal to root of AC, when you calculate, result is going to be 4.07. And question number 17. Okay. Imagine that you attach a heavy object to one end of a spring and then, while holding the other end, whirl the spring and object in horizontal circle like this. Does the spring stretch? Yes, it should, because as spring is whirled, yani, the mass starts to move in a circular path. To keep an object in a circular path, we need a centripetal force. And we said that any type of force in nature can be centripetal force if it keeps an object in a circular path. Yes, in here, this object is kept in a circular path by the spring. If no spring, cut the spring, that will not move the circular path. It will spin this whole way. This object in a circular path. Then, the force which provides circular motion of the ball must be a force in the spring. A force applied by the spring. So this force you are going to study in section chapter 3. It's called as spring force. Spring force. And spring force, also you will learn in chapter 3, sorry for this, but this title will be studied in chapter 3. This spring force is directly proportional to the amount of spring stretch. Now if you stretch spring more and more, this force is increasing. Then think now. You start rotating the object faster and faster and faster. FC equation, FC is proportional to, you can write it both in terms of Vt or in terms of omega because of square of both. Let's say omega, okay? If you make these objects rotating faster and faster, centripetal force to keep the object in a circle but must also increase. Which force is the centripetal force? Spring force. If I want this force to increase, you will learn, chapter 3, K is constant, it doesn't change. So X must, yani spring must be stretched to keep the object again in a circular path. Yes, spring stretched. Why? To keep the object in a circular path. As you start rotating the speed faster and faster, omega increases, Fc must increase. To increase Fc, X should increase, yani spring must be stretched. And question number 18. Why does the water remain in a pail that is whirled in a vertical path as shown in the figure? This figure is given in your book that way, but of course, it's not talking about this position because in this position, water is inside the pail. No problem. The point is top. When this pail is at the top, in this case, it will stay inside the pail or not. Okay. Now, take a pail of water and hold it like this. So will it stay inside the pail?
No.
And the problem, keeping it, will it hold like this? But you turn it upside down. No. The point is about then, you can get logic. If pail is at rest, it's impossible. So you should make pail moving. So pail must move in a circular path. But what is the condition? Yeah, moving circular path is not only enough. You should make this pail move in a circular path at some critical tangential speed. So assume that you are rotating this pail in a circular path with a great enough, more than great enough speed. This case. Then there are going to be two forces acting on the water inside the pail. One of them is, which never you can remove, which is Fg. Second one is, because the water inside the pail is in contact with the bottom of the pail. Water molecules are pushing the bottom up, bottom is doing reaction down, which is named as normal force. Yani, these two forces available. Fg always, but Fn depends on speed. If you rotate this pail at a speed greater than a critical speed, Fn exists. But at some critical minimum speed, Fn becomes zero. İşte, in this position, when Fn becomes zero, which force is the only force acting on the water? Fg. Yani if centripetal force is equal to Fg, in this case, minimum centripetal force must be equal to Fg to keep the water inside the pail. If centripetal force is going to be less than Fg, yani if your max speed less than that number, you are going to take shower. But if the speed is greater than this number, no problem. You can make it as great as possible if the bottom of your pail is enough strong. Otherwise, bottom will be broken because if fan increases down bottom, you have to like this. In fact, you can write this equation for what minimum speed you can keep it, but this is not content of our book. Then we should say that to keep the water inside the pail, so minimum condition is centripetal force must be gravitational force, and Fc must be equal to Fg. If so, Fc is equal to Fg, then go on with the equation. Fc is m times AC. Fg is equal to m times g. M will simplify for water's mass. So AC also must be equal to minimum free fall acceleration. Centripetal acceleration of the water must be equal to free fall acceleration. Then you can get. If centripetal acceleration is slightly less than g, again shower. Okay? How can be greater than? Okay. There's no limit if your bucket and pail is strong. Okay? Then, question number 19. Explain the difference between the centripetal acceleration and angular acceleration. Again, it's in fact similar to the question. Explain the difference between the linear speed and angular speed. And one of them is measured in terms of distance. The other one is measured in terms of angle. Similarly, apart this is a bit different. Centripetal acceleration and angular acceleration. Centripetal acceleration is because of the direction you change in a circular path. But angular acceleration is speed change. Yani speeding up or slowing down. Yani V omega changes or Vt changes. We calculate angular acceleration alpha, which was delta omega over delta t. But centripetal acceleration is because of direction change in a circular path. And question number 20. Comment on the statement, there is no gravity in outer space. So, there is no gravity in outer space means, because we know that every mass, of course, when we are talking about mass, we are not talking about small mass. Planets, stars, moons, satellites, all they have gravitational attraction on their surface. And this gravitational field strength, which is G, calculated by capital G, which is the universal constant, mass of the planet, or mass of that object, divided by radius of the planet, which is the distance from the center to the point which you measure the gravitational field strength. But as this distance from the space, this object is increasing, R increases, gravitational field strength decreases. And this is outer space, so far from this object. If it's so far from the object, G is that small, almost zero. Yeah, there is no gravity on outer space, means that. And next one. Explain why Earth is not spherical in shape, but what it is bulged at the equator. This is about the circular motion. We know that Earth is a sphere and it's a rigid object. And we know in rigid objects, angular rotational quantities are the same for every point. Now think about the rotational motion of Earth. Earth is rotating about an axis passing through the poles. When you put an object at the poles, because it is not in circular motion, there will be no centripetal force required for this particle, this rock, this soil, whatever, or this tree. But when you are moving away from the poles through the equator, so your body starts, or the particle starts to move in a circular path. They require a centripetal force to keep in a circular path. And as you go towards the equator, size of the circle is increasing, yani R is increasing, you need much more centripetal force as you are moving towards the equator. And at the equator, you are following, or the particles are following the largest circle. Largest circle, according to the equation of centripetal force, m/r omega squared, because omegas are the same because this is the object, but greatest R requires greatest centripetal force for the particle at the equator. But what if this greatest centripetal force is not provided? What is it if it is not enough? Then what will happen? Object will not follow circular path. According to law of inertia, objects must move away from the center in a straight line path, which will make the particles not to follow this path, it will move a little away, which will make the size of the circle to be greater. The only reason is that centripetal force at the equator, which is can be gravitational force between particles or cohesive force, adhesive force, whatever it is, forces, some of the forces acting as the particle, if not great enough, in this case object cannot follow circular path, which makes the Earth equator to be bulged a bit like an egg. Okay, and 22. Because of Earth rotation, you would weigh slightly less at the equator than you would at the poles. Explain why. This is a mystery question. Also, this question number 22 and 21 are related. First, you should know one thing. How do you measure your weight? You are putting a scale, you are stepping on the scale, you are measuring a number on the scale. That number, in fact, is action reaction force, an Fn, between your shoes and the scale. In fact, you are measuring Fn. But when you are in the equator, your Fn acting on your body and Fg are equal to each other. Why? Because in the equator, the equator, poles, sorry. Hiç söylemiyorsun ben. Yanlış şey söyledim bana hatırlatın ya. Yaşlı bıraklar unutuyorum, yorgunum. At the poles, your body is not in circular motion. So no centripetal force. So equilibrium. At the poles, your body is in equilibrium. That's why Fn and Fg are equal to each other. At the poles, you are measuring exactly the same number. You have whatever Fg is, Fn, same. But again, when you are moving from poles to the equator, so that your body starts to move in a circular path, and this circle is the largest red at the equator. So then now look at it here. Fg is towards the center. Sometimes it's downward on the earth. So it's towards the center if you look earth from outside, out of space. Fg is towards the center. Fn is away from the center. So now these two forces cannot be equal. We learned that the force which is away from the center is going to be less than the force towards the center. Yani, at the equator, Fn is less than Fg. But when you here, they're equal. What happened to Fn? Decreased. When you move from poles to the equator, Fn decreases. Yani, reading of your scale is decreasing, and you are losing weight. You think you lost weight, but it's not a fact. It is that. It is because of the circular motion of your body. How much less, according to this next centripetal equation, you can write it. Centripetal force is equal to the force towards the center, Fg minus Fn. So write Fn is equal to Fg minus Fc. Yani you are going to measure a number less than Fg. How much less? Fc, by amount of Fc. Fc, how can we calculate Fc? By this equation, m omega squared. R is maximum at the equator. If R is maximum at the equator, which means Fc is maximum at the equator. If Fc is maximum at the equator, Fn becomes minimum at the equator. That's why when you are at the equator, you are going to measure your weight smallest. That's why, what was the answer? Because centripetal force is maximum at the equator. This is a mystery question. This way they ask the mystery. Because centripetal force is maximum at equator, Fn is minimum, so you are going to measure minimum weight at equator. And question number 23. Why does mud fly off a rapidly turning wheel? Rapidly turning wheel. Mud, sticky things. It sticks on your body. Two different substances sticks each other. Because of a force between them called as adhesive force. In the secondary school, most probably you studied this. Adhesive force. It is the force between two different types of molecules. If the molecules are the same type, that force is called cohesive force. If different molecules, adhesive force. So the tires molecule and the mud's molecules are different. These different types of molecules attract each other, which is called adhesive force. And this force is keeping the bond on the surface of the wheel. But as wheel starts rotating faster and faster, according to centripetal force equation, let's try it. It was going to be mr omega squared. If omega increases, so centripetal force also should increase. What is centripetal force keeping this mod on the surface of the wheel? Adhesive force. If this adhesive force is not great enough, so what will happen? The mod cannot follow a circle. So what was the tendency? They will move in a straight line, but that's why they make a jet. While a tire is turning, rotating, you see the jets. These jets are following the path. You learn that path of an object. If centripetal force act on the object is zero, straight line back. Okay, they will be comparable path, but initially when they leave this jet so quick in speed, you see them a bit like a straight line path. Okay? So then what's the answer? Adhesive force between the mods and the tire is not big enough to keep the mod in a circular path. That's why mods particles are following straight line path and leaving the rapidly turning wheel. By the time, this can be a method for cleaning an object. Huh? If you clean an object faster and faster, you can clean it up. So also, drying is this way. Washing, it starts rotating faster and faster and faster and dry. Faster and faster and faster. So isn't then the air molecules inside this clothes, which is the adhesive force, becomes not great enough to keep this particle in a circle, but they are moving away. And then it becomes
dry.
Yes.
Teacher, adhesive force is the centripetal force here?
Yes, here, yes. Centripetal force keeping this line in a circular pattern. And question number 24. Astronauts floating around inside the space shuttle are not actually in a zero gravity environment. What is the reason? Actually, seems weightless, but not because it seems weightless. It doesn't say weightless. They think that they have no weight. Now the question is that, how do you feel your weight? Oh, I'm tired. Oh, I feel my weight. Because when I was sitting on this chair, my body pushes the chair down with a force, Fg, acting on my body. The chair action on the chair is Fg, downward. I know that every action is a reaction. This chair gives a reaction on my body, this is my Fg. Reaction force, Fn, is Fg. So I in fact feel Fn. I feel Fn, which is equal to Fg, then I say that I feel weight. You are right. And but this happens if my body pushes the chair down. What if I jump with this chair from second floor?
You want to do it.
So in this case, jump, the chair is falling down with G. I am falling with G, so I have no chance to push the chair down. So there is no action on the chair. There is no reaction on my body. Reaction force is zero. I feel no weight. I'm flying. So the result can be catastrophic. Okay, yani, in this case, these astronauts will feel weightless if space shuttle is diving with G, just like chair and me jumping from the second floor. So we're both of us, chair and me, falling with G. So I feel zero weight. Similarly, this space shuttle must dive with G. My body falls with G. Because I don't touch any place, I don't push any place, I don't feel my weight. But weight always exists. But we don't feel it because we don't touch anywhere. Okay? Alright, so then 24.